Let's assume there's an election taking place, and what we know already is that candidate red has 2,718,000 votes, and candidate blue has 2,700,000 votes even. Okay, let's assume that we're estimating that the votes remaining are 60,000. Now, what we're going to try to do is determine how many of the 60,000 remaining votes are needed in order for candidate blue to win the election or candidate red to win the election. Okay, so let's go through the logic. The votes required for a majority, we're going to use 50.1%, not 50.05, but we'll just use 50.1. It'll be close enough for this illustration. So we take the total votes we believe will be cast times 50.1%. Okay, so the votes required to achieve a majority would be the existing votes, and for candidate red, that's 2,718,000, less the votes required for the majority. So we're able to determine that for candidate red to win, 26,478 votes are needed. For candidate blue, we use the same math, only we start with what candidate blue has already received in votes. Okay, now let's prove that that's right. The total votes would be equal to candidate red plus whatever needed to achieve the majority. In the case of candidate blue, we'll take the 2,700,000 plus what we just calculated at line 7, the 44,478. Okay, and then if we divide that by the total votes cast, it should be equal to 50.1%. We get that for candidate red, right? We're dividing it by the total votes cast. For candidate blue, we take the number we just calculated on row 10, divided it by that same 5,478,000 total votes cast. Okay, next, if we wanted to calculate the percentage of remaining votes, then you would take the number of votes that they would need to achieve the majority that we calculated, where I'm pointing here on row 7, divided by the 60,000 for candidate red. For candidate blue, we would take the 44,478 that we calculated on row 7 and divide it by the 60,000.